Hello everyone. Hope am I audible? Can someone please let me know? Am I audible?
Yes, ma'am, you are
Okay.
audible.
Yeah. Okay. So it's like 3:15. So we will start. So first, I will start with my introduction. So myself, Shivangi. So I am the TA of this class. So I am doing my PhD from Indian Institute of Science, Bangalore. So basically, I'm working on the organometallics compounds, on the synthesis of organometallic compounds. So I will be like interacting with you people on every Saturday from 3 to 5 p.m. So if you people will be having any doubt, then you can let me know. Basically, this will be the interactive session because that Professor Prasenjit Ghosh will be giving lectures. So I will be like in hope like you people will listen that lecture, and if you are having any doubt, then you can let me know. I will not teach about that full course whatever he is teaching, because then there is no use of that because he is already teaching. So I will be taking the doubt sessions of you people. So if you are feeling any doubt in that lectures or in assignments, then you can let me know. I will discuss with that. um, uh, if the doubt, like if I will be knowing that questions, I will be knowing the answer, I will let you know immediately. But if not, I will maybe I will let you in the next class. So I will be happy if you people will talk in this lecture. You will interact, because this is basically just a TA session in which we will be like discussing about the course. It is not like I will be giving a lecture and you have to listen. You can ask me doubt, or you can interact whatever you want. So that's all. After that, I will like, if you people will introduce, after that I will introduce about the course. So today we will not be reading in more detail because this is the first class. So I will be taking the introduction of you guys, and it will be good if you will tell me your background also. So it will be good like if you will tell your background, so I will teach you accordingly, because maybe in this class people will be from, not all from chemistry, different background people will also be there. So yeah, can you people start your introduction? So I can see four of you which have joined. So so any one of you unmute your mic and give introduction.
Hello, ma'am.
Yeah.
I am Suraj Gupta and I am doing my master's in organic chemistry from Mumbai in KJ Somaya College.
Okay. And you are from chemistry background only. So you are doing chemistry. It means you are from chemistry background only.
Yes, ma'am.
So you are from Bombay.
Yes, ma'am.
So you are staying in Bombay, or for studies you went to Bombay?
No, I am staying only in Bombay. I
Oh,
stay in Bombay.
okay. It's good. So, Barsha, I can see your name. So, can you introduce yourself?
Yes, ma'am. I am Barsha Priyadarshini Padhi from Odisha, and I am doing my MSc at Sambalpur University.
Okay, so you are also from Orissa itself.
Yes, ma'am.
And in what, like, you are doing also in chemistry?
Yes, ma'am.
Okay. And the next is Rebad Raman Behra.
Yes, ma'am. My name is Rebhadraman Behra. I am from Odisha. I am doing my master from Sambalpur University.
Okay, so you are from Orissa itself.
Yes.
Okay. So, okay, so how many lectures you have attended for this course? Means, may I know like how many lectures he has taken and how many lectures? So yeah, one of you have joined. Subha Pratyusha. Can you introduce yourself? Hello, Shubha Pratyusha. Can you introduce yourself in like from which background you are? Okay, so I think you don't want.
Good afternoon, ma'am.
Yeah,
I'm Subhaprati Salenka.
yeah.
I'm doing my master's in chemistry in Sambalpur University. Thank you.
Most of you are from Orissa only, right? Sambalpur University. Okay, so Partha Pratim, can you introduce yourself? Hi, Pratha Pratim, can you introduce yourself? I think he don't want to introduce. Okay, so yeah, someone, can you please tell me like how many of you have attended the lectures and how many lectures he has taken and till what he has covered the syllabus? Maybe a fun class only. I don't sure. I'm not.
Hello.
Yeah.
Yes, I am on planning to
Hello.
not
Uh,
proposal.
no, you are not audible at all.
Am I audible?
Yeah, tell.
Okay, okay.
Okay. So I was asking something. Suraj, can you please tell?
Ma'am, sir has uploaded week one content, and in that he has started with history
Yeah.
and polarity of metal carbon
Carbon
bond
bond.
and reactivity.
Yeah.
Lecture one and lecture two on reactivity, and later on, lecture five is comprised of 18 electron rule. But I have completed only two lectures in week one.
Okay. Okay. And others, have you heard those lectures? Hey, you people can unmute yourself. Okay, I'm also a student like you people, so no need to worry about this. You can unmute your mic and you can discuss with me. I'm not a teacher. I'm just discussing with you regarding the course only. Okay, so it's okay. So I will share my screen. I would like to solve the assignment one. Okay, Pratha. It would be good if you introduce your name because it is Partha or Pratha. I don't know. So, okay. So I will be sharing my screen. For today I would like to solve the assignment number 1. So as the professor has uploaded that week 1 content, so in that assignment some of the questions will be there, which will cover the week 1 content. So I can also tell you the answers, but then it is of no use. If you people have heard those lectures, then it will be easy for you to answer those questions because it is nothing like to understand in those questions. Like that is history itself only. So the question is based on that only. So if you heard those lectures, then it will be easy for you. Okay, okay, sure, sure. So I will be sharing my screen. So before sharing my screen, I don't know I have to on my video while recording the session. Okay, so I will introduce again myself. Like I am Shivangi from Indian Institute of Science, Bangalore. So I am doing my PhD from here. So I am working on the synthesis of organometallic compounds, basically metal complexes, as an anti-cancer agent. So I took this course as I will be doing TA for this course. So this class will be doubt clearing sessions you can take. This will be a discussion class. I will be interacting with you people. If you are having any doubt, then you can ask me. and we will be having this class every Saturday from 3 to 5 p.m. Okay, so now I'm sharing my screen. So my screen is visible. Is my screen visible to you?
Yes, ma'am.
Okay, okay, fine. So this is the week one assignment. Maybe you people will remember these Nobel prizes and all. I'm not sure, but yeah, it's like not. We can just discuss. Actually, in this answer is there, so I will be showing one question. So this is visible, right? This question, first question is visible. Suraj, only you can tell. Others will not unmute your mic. I don't think so.
Yes, ma'am, it's visible.
Okay, okay. So first question is Paul. So basically, first I have to introduce the course. Then we will go for the assignment. So I will introduce the course. Yeah. So this is the course. So in this course, this is a 12-week course. So the course name is Transition Metal Organometallic Chemistry Principles to Application. So basically in this course, we will be reading about the transition metal organometallic compound. So the organometallic uh, chemistry. So can someone tell what are the organometallic compounds?
Ma'am, basically organometallic compounds, one would say like that there is a metal carbon bonding, but at the same time there are semi-metalloids which make bonds with carbon. So actually we say that there should be an electronegative difference of 2.5.
Yeah, exactly. So, organometallic compounds are the compounds in which there is at least one metal carbon bond, in which there is a sufficient difference between the polarity, then we will call it as organometallic compounds. So, this organometallic chemistry is basically it is at the interface of inorganic chemistry and it is and the organic chemistry. In organic chemistry, we will purely deal with that of the organic compounds, and inorganic chemistry are basically inorganic compounds. But when there is a bond between metal and carbon, then we will call it as organometallic chemistry, and those compounds in which there is one metal carbon bond with sufficient polarity difference, we will call them as organometallic compounds. So basically in this mainly the metal will be transition metal, and the carbon is carbon only. You all know the position of carbon in the periodic table. And the metal transition metal, when transition metal forms the bond with the carbon, we will call them as organometallic compounds. So we all know, maybe in BSc, I'm not sure you have read about this course or not, or this is the first time. Is this the first time you are reading organometallic compounds? Have anyone read this course in BSc, or this is the first time?
Yes, ma'am.
First time
No, ma'am. It
you
was
have
in
read.
BSc.
Okay, okay, okay,
Yes.
okay. Okay, huh. So we all know about the principles of the organometallic compounds. Basically, in these BSc and MSc, we will all read about the theory of these organometallic compounds, like how these compounds will be synthesized, what are the nature of these compound, electronegativity, polarity. But mainly these compounds, mainly metal complexes, are used in the treatment of various diseased models. So that is the main aim of this course, in which we will be reading this chemistry, organometallic chemistry, and we will be seeing that how the principle of organometallic compounds are so different from that of the inorganic chemistry, and it is helpful in the various application like in disease model also. So this is the course, and what is the course code? Course code, I don't know where is the course code. You have to remember these things, course code and all. This course is anno C 223 underscore CY52. So this is the course anno C 23 CY52, and this is the course name. And Professor Prasenjit Ghosh is teaching this course, and he is from IIT Bombay. So this is a 12-week course. So this is a 12-week course, and it has started from, I think, from 24th July. So end date will be 13th October for this course, and exam date will be 29th October. So in this, this will be the course layout in which you will be reading about these all things. So first week content he has already uploaded, in which he has covered the history of organometallic compounds, polarity and reactivity of metal carbon bond, reactivity of organometallic compounds, and then 18 valence electron rule. As in the p block element test and p block elements, they will follow 8 octet rule, but in organometallic chemistry we will be reading about the 18 valence electron rule. So the compounds which is having 18 valence electron, they are the most stable compound. So these I will not tell about all this, slowly you will learn about this. So this is the course layout in which this you all will be reading. CH activation, CC bond activation, CF activation, carbene complexes, carbines complexes. So this is a huge course. This is huge. Yeah. So till week 12th you have to read. So yeah, these are the books. Basics of organometallic chemistry by Professor B.D. Gupta and Professor A.J. Elias, and Crabtree organometallics. These are the two basic books which you have to read. Okay, so now we will go to the assignment number one. Is here. Yeah. Hmm. So this is the first question. The first question is, Paul Ehrlich was awarded Nobel Prize in Physiology for discovery of. If somebody knows, then they can unmute your mic and tell me the answer. It will be good if you people will tell. I can immediately tell the answer, but then there is no use of doing these assignments and all. You have to submit the assignments also. If you will be like doing in this class, then it will be easy for you to submit. Right. So can, if somebody knows, please unmute your mic and give me the answer.
Selverson.
Yeah. So Paul Ehrlich was awarded Nobel Prize in Physiology for discovery of Selvarsen. So what is Selvarsen?
Selverson is a disease transmitted by, like, what we can say that. Uh,
Actually, Selvarsen is not a disease. Selvarsen is an arsenic-based compound. Uh,
okay.
yeah, so Selvarsen is an arsenic-based compound, which is known to cure one disease, that is syphilis. Syphilis is a disease which is transmitted. This is one kind of infection, and it is transmissive disease. So, so this is the drug which is known to cure syphilis disease. So this salvarsan is an arsenic based compound. So I will show you, this is the salvarsan. Actually I was reading about this. So this is the salvarsan. It is a drug. So this is an arsenic based drug. So here this is the metal, and here this is the arsenic carbon bond. So this is the organometallic compound, for which he got the Nobel Prize. Oh my God. Okay.
Okay, ma'am.
Yeah. So, okay. Now you can you can see the answers too. So the second question is, H.C. Brown was awarded Nobel Prize for his work in. H.C. Brown was awarded Nobel Prize for his work in.
Ma'am, hydroboration reaction.
Yeah. So H.C. Brown got the Nobel Prize for hydroboration reactions. So hydroboration reaction. Um, do you know about hydroboration reaction? This is very simple and like basic reaction.
Yes, ma'am. We take a olefin and we react with like BH3 or alkyl substituted
Yeah.
BH
Yeah. Yeah.
BH bond and like additions takes place. Hydrogen and boron adds, and later on we remove boron from the, and there is a formation of alcohol. Right.
Yeah, yes, exactly. So hydroboration reactions are the reaction which leads to the oxidation of alkenes. So in alkene there is C double bond C bond. So after cleaving C double bond C bond, single bond will be formed and there is addition of OH and H at two carbons. So that is basically the hydration of alkene, or we can say the oxidation of alkene, which is done by the this borating agent, boron based reagent. So we will call it as hydroboration reaction. So H.C. Brown got the Nobel Prize for his work in the hydroboration reactions. Yeah, so this is very simple question. So this is very simple question. The covalent radii, it is very simple. It is just based on the, if you know the position of these elements in the periodic table, you can easily answer. Uh, I want, like earlier, Suraj was giving this answer. If I can't see the screen now. So can someone else give me the answer? This is very basic. I think no need to hear those lectures also. This is very basic. So you have to tell the radii trend, the correct order of covalent radii of carbon, silicon, germanium, and tin. So what is the trend? Barkha, is she here? Hello, I don't know how many people are there. Yeah, many people are there. First man. So first is the tin, germanium, carbon, and silicon. Yeah, so first is the answer. I will see the periodic table. So this is the periodic table. So carbon, silicon, germanium, and tin. So as we move down the periodic table, the covalent radii increases with increase in the number of shells and um, electrons in those cells. As a result of which, the covalent radii of these elements increases. Actually, I can't see your answers on the screen. It's okay. So, sorry. Huh. So the correct order of mean bond enthalpies of D bar in kilojoule per mole, dimethyl zinc, dimethyl cadmium, and dimethyl mercuries. But you have to give me the explanation. I also don't know like why, what will be the answer. Can someone tell me? You people are not telling me anything. Suraj, you know this answer?
No, ma'am. I also have not read about this question.
Anyone else?
Ma'am,
Yeah.
Parth is saying answer is second one.
Part, can you explain that why second one? You can explain your answer in chat also. If someone is seeing that answer, you can tell me. You have to explain that why second is answer. I also don't know about this question.
Ma'am, he is saying like methyl mercury bond is very strong.
In case of mercury.
Yes.
Why it is weak in the case of zinc?
Ma'am, he is saying in case of mercury because of diffuse orbital.
Okay. So whatever he is saying is correct only. Like on Mercury, there is a diffused d orbitals, but so according to him, if more diffused d orbitals are there, then how bond enthalpies are strong in the case of Mercury? Then I think so. Trend should be opposite. If the orbitals are diffuse, then it is difficult to make a bond with this small ligand. Methyl is like CH3, just CH3. So in this case, the bond enthalpies will depend upon the nature of the metal and the nature of the ligand also. So in this case, if we will see in zinc, dimethyl cadmium, and dimethyl mercury, so all the ligands are same. So in these kind of compounds, the two factors are responsible. One is the nature of metal and other is the nature of ligand. So in all the three cases, ligand is same. So we can rule out about the ligand. So now we have to basically concentrate on the metal. So the first metal is zinc, cadmium, and mercury, and both are in same +2 oxidation state. So, but as we go down in the periodic table, if we will see, so zinc, cadmium, and mercury. So as we go down in the periodic table, the mercury has the more diffused d orbitals, whereas it has to make the bond with the methyl, which is having more s character. So it is having more diffused d orbitals. So the compatibility of forming bond is less in the case of dimethyl mercury in compared to dimethyl zinc. So the correct order of mean bond enthalpies should be dimethyl zinc, dimethyl cadmium, and then dimethyl mercury. Whatever reason he was telling is right only. This the reason is based on the diffused orbitals, but the trend should be opposite.
Ma'am, what is the difference between bond enthalpy and mean bond enthalpy?
What is the difference between bond enthalpy is the energy which is provided to break one bond. Okay, so in this case, if you will see, if only zinc methyl will be there, we have to break just zinc methyl bond. But in this case, two methyl are there. So first methyl will break its bond. So it will be, if we will say delta H1, and then second methyl will break its bond, then it will be delta H2, and the mean bond enthalpy is the mean of these two enthalpies, whereas the bond enthalpy is a single enthalpy. Understood?
Ma'am, delta H1 or delta H2 both are equal or opposite? মানে not equal.
No, no, it will not be equal. It depends. Means if this is the stable complex, so first methyl, if we have to cleave the bond, first methyl with zinc, then it will take more energy because we are cleaving a bond which is more stable. After that, one species will form or one intermediate will be formed which is less stable than that of dimethyl zinc. So in that case, that bond will cleave easily. That driving force will be the stability. So the delta H1 and delta H2 can be equal, but it is not necessary. It depends upon the intermediate state. Understood?
Yes, ma'am.
Yeah. So this is the mean bond enthalpy and bond enthalpy. So it is not equal, but it depends upon the intermediate stage. If after cleaving one bond, the intermediate stage is stable, then the second bond enthalpy will be high because we are cleaving the stable species. But if the second intermediate state whichever is forming is less stable than that of the basic or parent compound, in that case the second bond enthalpy will be very low to achieve the stability. Am I clear to all?
Yes, ma'am.
Yeah.
Yes.
Yeah, so the answer will be first in this case. So Parth, his name is Parth, I don't know. So am I clear to you? So the first is the answer. I don't know. He's not telling anything. Okay, so
Yes, ma'am. He is saying he is clear. Here.
okay. So the fifth question is the correct order of mean bond enthalpies is mx bond of AlC, AlO, and AlCl. The correct order of mean bond enthalpies d bar kilojoule per mole of AlC, aluminium carbon bond, aluminium oxygen bond, and aluminium chloride bond.
So, ma'am, it should D1.
Yeah, it should be D1 only. So it should be D1. So can you explain your answer?
Ma'am, as central atom is fixed,
Yeah.
but side ligand is changing. That is chlorine, oxygen, and carbon, and we consider chlorine atoms. So overlapping will be more stronger in case of aluminium and chlorine as compared to aluminium oxygen because 2p orbital is involved, and in case of carbon, it's also a 2p orbital. But when we talk about oxygen and carbon, then we should apply the electronegativity concept.
Yeah, so it's yeah, so your answer is correct only. I Okay, so the answer is third.
Okay.
Huh. So okay, in this case, we have to apply the electronegativity concept only. This inorganic is like this only. We have to apply different concept. So in this case, what happen is we have to see the electronegativity out of carbon. As you said, this is correct. Aluminium is fixed, so we have to basically concentrate on carbon, oxygen, and chloride. So out of carbon, oxygen, and chloride, if you will see, the oxygen is more electronegative than that of the chloride, right?
Yes, ma'am.
So if it is more electronegative than chloride, so the aluminium is more electropositive and oxygen is more electronegative. So in this case, there will be ionic interactions. So strong ionic interactions are involved in the case of aluminium oxygen as then aluminium chloride, and then there is no ionic interaction between aluminium carbon bond. So aluminium carbon bond, or we can say that metal carbon bond, which we are studying in that of organometallic chemistry, are weaker as compared to aluminium yeah, metal X. Any metal and any X, it may be halide or any electronegative element. if the question will come like this, then you have to basically see the options in, also in net, IIT, jam, whatever paper you will give, you have to solve the questions like this. So in your, if you will be confused in these two, in four options, first you have to rule out the two options. But how you will rule out two options? It will be like that. So you should be knowing the concept. The aluminium carbon bond or metal carbon bond is always weaker than that of the metal X bond, provided X should be electronegative. So it is always weaker than that of, anyway, this is weaker than O and C, Cl. So first two option. So, but I'm telling, I am also confused. 1 minute. Yeah, so it is always weaker. So the first two option we can rule out, in which they are saying that aluminum metal carbon bond is stronger. So these two option we will rule out. So now these two options left. So in these two option we have to see which we have to tick. So basically this is based on the electronegativity, and oxygen is more electronegative and hence the most ionic interaction than that of aluminum chloride. Then we will say that option number 3 is correct. So like this, you are always there in question. If you will see the answer, two option simply we have to rule out by a simple concept. Then we have to see, or we have to think about the two other options. So in this, the first two option we can rule out, because aluminium carbon bond can never be stronger than that of any of the metal X bond, provided that X should be electronegative. Understood?
Yes, ma'am.
Yeah. So the next question is very simple. So wait for 5 minutes. Yeah. So the next question is very simple. So the type of metal carbon bond present in the compound. So this is the compound. So what is the metal in this compound?
Sodium.
Yeah, sodium is the metal and carbon is of the acetylene carbon, that alkyne carbon. So which kind of bond is present between metal and carbon? Is it hydrogen bond, van der Waals bond, ionic bond, or covalent bond? Hmm. Can someone tell which kind of bond is present between an AC here?
Ionic.
Ionic.
Yeah, it is ionic bond. So how this compound exists? This compound will exist as Na positive and C triple bond CH negative. So the interaction between metal and carbon is ionic here. So the third option is correct, ionic bond. That should be, yes. Okay. Okay, this is also very simple question. We will learn about this. We will read in very earlier classes. So when methyl iodide will react with mercury in the presence of sunlight, or we can say that H nu, then what product will form? Hmm?
CH3HGI.
Yeah, CH3HGI. Methyl is carbon. This is metal mercury. So metal mercury bond is forming here, and it is very toxic. We should not use it in the lab. This is very toxic. So methyl mercury iodide CH3HGI will form. Yeah. So the Nobel Prize for olefin metathesis was conferred in, again this is the fact only, you have to remember this thing in which there is nothing to understand. If you heard about those lecture, maybe one of you remember this. I also don't remember. I have to see the answer. If somebody knows, then you can tell.
2005.
Okay, so Nobel Prize for olefin metathesis was conferred in 2005. Okay, yeah, fine. Yeah, the correct statement about stepwise bond dissociation energy given by D1 bar and D2 bar for Dimethyl mercuries. Okay, so someone has asked me the question, what is the difference between bond dissociation enthalpy and mean bond enthalpy? So in question, this ninth question itself, your answer is, so D1 bar, when first methyl will dissociate from mercury, so then it will be D1 bar. And when second mercury will cleave, then D2 bar. And the mean of both D1 bar and D2 bar individually, this is bond enthalpy. But when we take mean of D1 bar and D2, it will be mean bond. So, can someone tell what is the correct statement for this compound? The first option is the D1 bar bond dissociation energy is 214 kilojoule per mole. The D2 bar bond dissociation energy is minus 29 kilojoule per mole. Both D1 bar and D2 bar is identical. No, it should not be the answer. Third should not be the answer. And then the bond dissociation energy of D2 bar is higher then D1 bar. Like now you can see all the four options. According to your concept, you have to build like third and fourth option you have to rule out because third and
Yes, ma'am.
fourth option should not be considered because D1 bar and D2 bar should not be identical. Why? When methyl, this is stable compound. You can see right HgMe2. This is stable compound. If you will cleave this, then it will exist at Hg plus Me negative. It will be very unstable. So when it will be very unstable, it immediately cleave the second bond with methyl and it will exist as Hg plus 2 in gas phase, which will be more stable than that of HgMe. So D1 bar should be higher than that of D2 bar. So the last option is saying D2 bar is higher. So this is wrong. We can rule out fourth option and D1 bar and D2 bar can never be identical as I told you. So the option should be from first and second. Okay, so third, fourth we can simply rule out. Like this only you have to solve in NET, IIT, JAM, all these. You have to rule out two options. You have to think about two options, whichever remaining. So you have to think about this. Now I think if you have remembering those values, maybe someone can answer. As also, now the answer is here only. The bond dissociation energy, we have to provide the energy for dissociating the bond. If we have to provide the energy, then it should be positive. If the energy will be like, if the bond will form, the energy is released. And when the energy is released, then it will be negative. Now we have to provide the energy to dissociate a bond. It should be positive. So what is the right answer?
Option A.
Yeah. So in question itself, if you will like clearly see, the answer is A only. If nobody has read about this concept, even by the concept we can answer this question. It should be option O, A. Hope it should be A only. Yeah. So the option A is correct answer. Okay, understood. Like this, you have to solve the MCQ.
Ma'am, how option D is eliminated?
Yeah, option D is eliminated because you see they are telling like D2 bar is higher than that of the D1 bar. So now you have to see the intermediate stage. If you will cleave first methyl from this species, first you will see the basic compound is dimethyl mercury, right? So dimethyl mercury is stable. So if you will cleave one methyl, this will give Hg positive methyl negative. The first bond dissociation energy is D1 bar, so it will lead to the formation of Hg positive, Me negative. So the intermediate species is this one. So this is very unstable species and it will immediately cleave the bond even if you will provide very less energy, even then it will cleave the bond to form the Hg plus 2 in gas phase because ion itself is more stable than that of this species. So D2 bar can never be higher than that of the D1 bar. Understood?
Yes, ma'am.
Yeah. So like this, you have to solve the MCQs in all the competitive exams also. So, okay. So this is the last question, I think so. Huh. So the pair that displays the maximum difference between the highest MMe3 bond dissociation energy and the lowest MMe3 bond dissociation energy are. So this is very simple. Again, in this ligand is same methyl, methyl, methyl. Depending upon the nitrogen phosphorus, arsenic, antimony, and bismuth. If you know the position of these elements in the periodic table, simply you can answer which one will be the higher difference. This is the periodic table. So nitrogen, phosphorus, arsenic, antimony, and bismuth. N, P, As, Sb, and Bi. This is the periodic table. You can see the position, and now you read the question and then give me the answer. The pair that display the maximum difference. You have to choose a pair which will show the maximum difference between bond dissociation energy.
Option number D.
Yeah, option number D. Because if you will see the methyl is fixed, and if you will see the position of these elements in the periodic table, nitrogen is at the top, bismuth is at the bottom. So the we will cleave whatever bond they will form. Nitrogen and bismuth will, the difference between nitrogen and bismuth will be more. So the option D is correct. With this, the I think assignment one is fixed. I think it is over. You got your assignment first or no? You got assignment first from professor.
Yeah. Yes, ma'am. Yes.
Is it same or is it different? Have you
I
seen?
think I think so. I have to check again.
Okay, okay. If it is same, then it is fine. If it is not same, then you have to, I think so, share with me. I don't know how to assess that assignment.
I think questions are changes.
Question changed.
Yes, ma'am. In our assignment, there are different questions.
Why I can't assess those questions? I don't know. I tried actually. This is 2023, right? So I should also assess. I am not having any access of this. You see here, this is 2023 lectures only, I think so. But here there is no assignment here. I can't see any assignment. From where we are getting this assess of assignment? Can you show the assignment or something like? Can you share with me? Is there any option to share with me?
Ma'am, we can mail you.
Ha ha ha. You can mail me, right?
Yes.
It is good actually. Shall I write my mail ID here?
Yes, ma'am.
Where is the meeting? Divert chat mechanism was first question. Okay, okay. But how divert chat mechanism is the first question? In first week, he has not taught about divert chat mechanism, or is it covered? I don't know.
Ma'am, they were chat mechanism, I guess so. He has been talked in like history only,
Okay, okay. It will be
or
covered in maybe second week fully.
yeah, or he may be covered in third or fourth lecture. I have not taken those. No.
Okay, okay, okay. So this is my mail ID I have shared in chat. Please, someone of you, if share the assignment, then it will be good. We can solve actually. Because you see, if we have solved one assignment, it is 1 hour only. We have to give 2 hours for this TA. Anyway, maybe this is the first class. From the second class, we will be solving maybe two assignments, one from the previous and one from this, whatever you people are getting. So you have to maybe share with me every week whatever you people are getting. Then we will solve all those assignments. It will be easy for you also, and it will be helpful in your papers also. So, okay. So in this assignment, has someone, means, do you have any doubt which question we have to discuss again, or if someone is feeling any doubt. I will share with you this assignment. You people can also try. Okay. You can unmute and tell, right?
Yes, ma'am. Yes.
Okay. Okay, so if you have any doubt, then you can ask. Otherwise, we can leave this class. Maybe we will meet on next Saturday, 3 to 5.
Ma'am, can you resend your email ID because
Oh,
I was left in between?
okay, okay, sure. I will resend means in chat box only, right?
Yes, ma'am.
Okay, yeah. Shivangi, yeah, I sent again. Ma'am, can you discuss something about net gate exam perspective or PYQS? This PYQS means PYQS in this platform. Okay, previous year question. Okay, yeah, we can discuss. There is no problem. That's why I means we can. That's what we solved this assignment. I can simply tell you the answer, right? Or I can simply ask you the answers also. Maybe some of you might be knowing the answer. This is not first time you are reading this course, but the main perspective in which I was teaching is that only, like how to rule out the two options and how to think about the remaining two, because if you are ruling out the two options, then we will be we left between two, then it will be easy. I think so, like this only I have prepared for my exams also. We will be reading about, I will teach you in this direction only. And if you're feeling like if you are having any doubt in previous year questions of net, then you can ask me. You can bring question paper of net gate. Yeah, but I need time for that. Maybe I was not remembering fully, I have to take time. Maybe if you will ask in today's class, I will not be able to answer in today's class. I will take some time and I will give you the answer maybe in the next class. But if you are feeling any doubt regarding this course or in the net gate, like any of you, if you are finding any problem, you can ask me. No problem with that. And we will be solving that assignment in that perspective only. That's why I am asking. Like if we will be solving two assignments, then it will be helpful for you regarding this course also and this netgate also. Because if you will see the like total syllabus for that UGC net also, the organometallic course is having a huge weightage in that paper. Maybe some uh, 12 to 15 marks paper will be coming from this organometallic chemistry. So your basics and your concepts should be strong, like in this course. This huge weightage is there. So you should not like you should not just say ratta nahi marna hai. You should know the concept. Like if you will be knowing the concept, then only you can rule out the options. If you will be knowing the concept, if in hurry you will not be able to read the full organometallic chemistry and your basics are clear, then also you can solve some of the question. Like in methyl mercury, whatever I told you, like this can't be negative. I am talking about this question, I will show you again. Yeah. So maybe this question, if you will see, no need to know anything about this. If you know the basic, like what is bond dissociation energy and how this, what is the stability of this compound itself, then there is no need to read of organometallic chemistry. If means if in hurry you will, like we can't read all full syllabus of UGC net, we have to select some of the things. Okay, so what we have to read. So if in hurry you leave the OMC, organometallic chemistry itself, if a person is having a good hold on his concept, then they can answer this question. Even this question also, you can see methyl is same only. Like this you have to solve. Like what is the diversity in the question? If you will see, in all the option methyl is same. It means we have not to focus on the methyl because it is same only. The question is N, P, AS, SB and BI, and if you know the position of these elements in the periodic table, any of you can answer. And this question also, like this is like this you have to answer. Nothing big in this. So like this you have to do, and we will be solving netgate question, no problem with that, but you have to bring that question and you have to give me the time, because now also I'm doing also PhD. Maybe I am not remembering. I forgot. Now it's 3 years back I have cleared that exam. So we can solve it, no problem, but you have to bring those questions if you are feeling any doubt. And maybe every week you have to share me the assignment, because I can't see the assignment. Then we will be solving two assignments maybe per week. And yeah, I want you all to unmute your mic and interact with me, as it is interactive class only. I'm not any professor that you can't talk. I'm also a student like you. If you are having any doubt, you can ask me. I may also not be knowing, but all we will read together and we will, means if I will be knowing, I will let you know. Okay.
Okay, ma'am.
So, okay, now I think if there is no doubt, this is the first class, but we should not leave before 2 hours. But if no doubt is there, then can we leave?
Yes, ma'am.
Okay, so okay, bye bye. I'm leaving. Sorry for today. Bye. I think you are outside. Too much noise is there, right? That's why I think you are not able to talk. It's okay, no problem.
Ma'am, can you again explain the question number 4?
Yeah, sure. Which is the question number fourth? Okay, so this is the question, right? Yeah. So in this question, we have to tell the bond enthalpy, right? So these are dimethyl zinc, dimethyl cadmium, and dimethyl mercury. So methyl is fixed again here, and the question is zinc, cadmium, and mercury. And in mercury, 5d orbitals are involved, which is more diffuse than that of the zinc. So as the number of d orbitals are increasing, the polarizability of that metal increases and the tendency to make the strong bond decreases. That's why dimethyl zinc is forming strong bond than that of cadmium and mercury, and hence their bond enthalpy is more stronger or greater in zinc than that of the methyl. So option A is correct.
Ma'am, can we introduce here the electronegativity concept?
Actually, electron,
Ma'am, I think,
can you
ma'am,
explain me like how you will be able to answer? I can't see the electronegativity difference much. If you can explain.
there is no,
Yeah,
no, there is as such no any electronegative difference. Approx zinc, cadmium, mercury in the
yeah.
same group, but down the group the electronegativity decreases, I think. And
Also then electronegativity decreases, right?
yes, ma'am.
So
Ma'am, I think that electronegativity is, we can see here the zinc and cadmium and mercury. Zinc has more
more
electronegative.
electronegativity, yeah,
Yes, ma'am.
yeah.
And I think here the electronegativity difference is more here in case of zinc.
Zinc, yeah. Then
Uh, that's why the ionic character here, no ionic character is there, we know, but as we can see that the electronegativity difference is little bit working here, so we
more in
can
the case of zinc, you are telling. Then zinc
yes, ma'am.
should be having high bond dissociation enthalpy,
Yes,
right?
ma'am.
Means,
Yes, ma'am.
whatever you are telling is right only. Means it is like MCQ answer. You means different people have different mind, right?
Yes,
So
ma'am. Yes,
whatever
ma'am.
concept we are feeling here, we can apply. As this is MCQ, no one can deduct your marks. As many people are there, okay? So different concepts will hold here.
Yes, ma'am.
So as far as your answer is correct in MCQ, so no need to worry. But if that
Yes,
is
ma'am.
controversial, then there is a need to worry, like why we have to hold on that concept only.
Yes, ma'am.
Okay.
Ma'am,
Yeah.
again down the group is 3D, then 4D, then 5D.
Yeah.
So there are 4D to 5D when we are going down the group.
Hmm.
Then we have more diffused orbital,
Orbital. Yes.
and as we have more diffused orbitals, then they can make good bonds in them. So
Mm,
why we put here?
I did not get you actually. More. What is?
Ma'am,
Yeah.
as uh, ma'am, as we are going down the group from 3D to 4D, then 5D,
Yeah. Yeah.
then we have 3D, that is less diffused orbital than 4D and 5D. As the 3D to 4D and 4D to 5D is the more diffusion of the orbital increases, they can make a good bond with methyl.
No, no. Yeah, polarizability is increasing, but methyl is itself is a very small ligand, but we have to see the compatibility too.
Okay, ma'am.
Yeah, that compatible. That's why we are reading about the overlap. Like SS orbital is more good.
Hmm.
If this is the case, whatever you are saying is, then S should overlap good with that of the D, because D is having
Yes,
more
ma'am.
polarizability. But it is not the case. D is having more
Yes, ma'am.
polarizability because it can
Hmm.
diffuse at the big. But we have to see the nature of ligand too. But here the ligand is very small. But if you are considering any ligand which is very big
Hmm.
in, like if you will consider any ligand, I don't
Yes, ma'am.
remember any ligand, but if you will consider any ligand which is like bigger in size, then maybe the answer will be different. Then in that case we will see the nature of the ligand too. But
Okay,
if
ma'am.
we are seeing here the nature of ligand, it is very small methyl, so we have to see the compatibility too.
Okay, ma'am.
Yeah, understood. But if the ligand size is also increasing with, in like instead of methyl, different ligand is there which is having bigger size, then maybe mercury is the good. Mercury is having high bond enthalpy, because then although its polarizability is increasing and d orbitals are introducing, but the ligand itself is higher in size, it can make a compatible bond with that of the mercury than that of the zinc. In that case, answer will be reversed. But here you have to that's why MCQs are simple, but we have to see all the factors. But here, if you
Yes,
will
ma'am.
see, you have to consider the ligand nature too. Here, the ligand is fixed, but the ligand is small. So you have to see like which metal is small, which is showing good interaction with that of metal. Then you have to give your answer.
Okay, ma'am.
Okay, understood.
Yes, ma'am. Ma'am, but polarizability depends upon the electronegativity character, na?
No, polarizability is depending upon the
Ma'am,
size.
yes, ma'am. Ma'am, as we can see here, the polarizability zinc is more than it. Okay.
No, no. Polarizability, you are misunderstanding your concepts. Polarizability is depending upon the size. Here, in all the cases,
Yes,
if
ma'am.
you will see the charge on all the metal, the plus two is on
Yes,
is
ma'am.
on that. Zinc is also plus two. Cadmium is also plus two. Hg is also plus two. But as we go down the group, the size is increasing. Here, plus 2 is localized in this much small circle, but here in cadmium it is big, and in mercury the plus only plus 2 is there, but it is more polarized, it is at the big space. So
Yes, ma'am.
it
Yes,
is
ma'am.
associated with that of the covalent radii, or we can say that it is associated with that of the size of the metal,
Yes, ma'am.
not with the electronegativity.
Yes, ma'am. Size and the charge factor is
Yeah,
also there, na?
charge factor is responsible. Yeah,
Yes, ma'am.
but charge and electronegativity is different, so you should not confuse
Different.
with that of the
Yes, ma'am.
electronegativity.
Yes, ma'am.
Okay, so
Yes, ma'am.
understood.
Yes, ma'am. Thank you.
Huh, okay. Anything else? So anything else?
Ma'am,
Yeah.
can you explain how to manage our times and prepare for a net and gate?
This is very
And
difficult question. But yeah, you have to focus on Netgate also, because now you are at the peak time. You are in masters, right?
yes, ma'am.
So this is like You're in MSc first year or second year?
First year, ma'am. First year and first semester.
Ah, then no need to worry. You have too much time. But yeah, if you will be managing from now on, then it will be good for you.
Yes,
Uh,
ma'am.
Start.
Ma'am, what is the
Start.
rank of your in CSI and NET and GATE?
actually, my rank is I was 42 rank. Yeah.
Ma'am, gate.
No, gate
Net.
with net. That is UGC serious, yeah. UGC net.
Okay.
So that was 42. In GATE, actually, when we will be reading for too much time, na, so net will come first, then GATE. So if our net exam, we will be giving with like, we will be knowing. In exam also, we will be knowing, like, yeah, I am giving best, so it will be clear. Like, this we will be knowing. So I gave my net exam. Then in my mind, it was like that, yeah, this time I will clear this exam because I wrote the exam in very good way. Then I lost my focus. Then I did not read much about the gate because we will be reading for net gate for 6 months. Then we will be too
Yes,
much
ma'am.
frustrated. Then somehow we have to escape from that. Then I did not read much about the gate. So in that case, yeah, I did not get the good rank in gate. But yeah, I cleared that exam too. But
Yes, ma'am.
yeah, but if you will be having potential to clear the gate, and if you will be coming in some 1 to 50 or 100 rank, then it will be very good. You will get some good position in ONGC and all, and that is actually very good. But yeah, meantime you have to read about this netgate. This courses also you have to read. But yeah, this is true, like you have to manage your time and you have to read. Maybe you are in MSc first year, first semester. This is
Yes,
the
ma'am.
time not to take much stress, but yeah, this is also a good time to manage your time and read in a proper direction, so that you will not be stressed in MSc fourth semester. So
Ma'am,
Yes.
how was your interview in IIC Bangalore?
actually, in IIC Bangalore, what they do is like the good thing in this is they will not, although they will send you like call of interview on the basis of you CSI or UGC ranks and gate ranks only. But the good thing
Yes, ma'am.
here is like they will take two interviews here, like that vigorous selection is there here. You have to clear two rounds, and
Yes,
all the
ma'am.
people, it is not like only IIT and all the only IITs they will take. It is not like that. The people from universities, like in IISc, getting a position is like you should be having good basics, concept
Yes,
should be
ma'am.
Ma'am,
clear.
ma'am, from where your MSc completed?
Actually, I am from Punjab. So I completed my MSc from Amritsar. That is also a university, state university. So,
Ma'am, we are also in our state university.
haha.
Yes, ma'am. Sambalpur in Odisha.
Many people are there from Orissa and even from Sambalpur. Some of my friends are also there. No worry, you people will clear. Don't worry. Don't take stress. Enjoy.
Yes, ma'am.
Hmm. So yeah, so you have to clear two rounds, like two interview rounds here, and then yeah, you will get chance to come in the ISC. If you people will be coming, I will be here. If I will be here, then you can call me. No problem with that. But yeah, you are having lot of time. Read a lot. Clear your basics. रट्टा नहीं मारना है, basics clear करना है. Then surely net will also clear and you will be uh, placed at a good place. No worries. Okay.
Yes, ma'am. Ma'am, how was your preparation strategy?
Yeah, like that only we have to clear. Means our maybe in our case, what we are thinking is like concept. In some cases, लोग बच्चे रट्टा मारते हैं, हम नहीं जानते कंसेप्ट क्या, बट इन सम केसेस वी नो द कंसेप्ट, बट टाइम मैनेजमेंट विल बी वेरी डिफिकल्ट इन यूजीसी कि 3 hours will be less. Actually, we have to manage our time in paper also, and we have to, in our mind it should not be like that, like I have to prepare full chemistry. We have to find the topics on which we have a good hold. if we are not having a good hold on the quantum mechanics like physical chemistry, some of the chapters we can leave. It is not like we have to read full chemistry. It is good if someone is too much, it, like if he or she is having too much potential, they can read full too. But the thing is, like, we can't read full. This is also a true fact. We have to find some topics in which we can see, like, we are having good hold. And some of people are good in organic chemistry, but some of people say on the same, if we are considering an example of a same person, maybe he is good in organic chemistry but not in physical chemistry, then he has to understand and accept the fact, like, okay, I will invest my time mainly on the organic chemistry. So it should not be like that. Okay, I will read organic too, I will read physical too. And in the paper, if the question will come from organic and physical, then he will not be able to answer of both. We should be having good hold. Okay, I am preparing the organic chemistry. If some question will come of organic chemistry, I will be able to solve that question. Like that, you have to prepare.
Okay, ma'am.
Yeah, so like this, you have to do. And you have to see the chapters, like which is having good weightage in that exam, like organometallic chemistry is a good example. Coordination chemistry is also having too much weightage in net. Quantum chemistry is having too much weightage. And also spectroscopy is a very good topic to cover for net, like nuclear magnetic resonance, NMR, proton and 13C. Like that, you have to choose your topics in which you can prepare, or you can take a hold on that topic, so yeah, that you will be able to answer.
Ma'am, when you cleared your net during MSc or after MSc?
Actually, I have cleared my exam. I wrote the exams during my MSc too, but I wrote exam only once, like in my last semester. But that time I was not able to clear. Then after my MSc, after I left my MSc, that time I gave exam one more time. That time I cleared my exam. Means it is
Yes, ma'am.
basically after MSc.
Yes, ma'am. We are having a lot of problems in MSc now. Means ki, we have the semesters and classes so much here,
I,
and we,
I don't understand. I am having one doubt. Actually, why you people are taking, means this is good. You people are taking NPTEL courses, but in university itself, our professors will be there. Now, then why we have to take it
ma'am,
as online
um,
classes?
ma'am, NPTEL here in our course is just 3 credit course. That's
Okay.
why we are taking. Yes, ma'am.
And in your, like, place, like in your university, Sambalpur University,
Yes, ma'am.
organometallic course, nobody will be there to teach. Means like you
Yes,
people
ma'am.
are covering on, why you people have to cover on through online. Means like I was, means if I will consider my example, I was from Punjab. Okay, so I was reading from that university, and professor come used to come and teach you in the class only, like they were offline classes.
Yes, ma'am. We are having our offline classes, but the NPTEL course, SOYAM course, um
Okay, this
this
is
course,
mandatory to cover these
yes,
credits
ma'am.
too.
Yes, ma'am. We have to
Oh,
cover this from NPTEL only.
okay, so you are taking offline classes too and also
Yes,
online
ma'am.
classes, so this is mandatory.
Yes, ma'am.
And offline also you are taking organometallic course.
Yes, ma'am.
This
Ma'am,
is
here in NPTEL courses,
Mhm.
there are a lot of courses, like 14 to 15 courses are there. Uh, so we have to choose one of them. So we choose here the organometallics,
Okay, okay.
and
So how much credits you have to like complete for NPTEL?
3 credits.
Each semester 3 credits.
No, ma'am. In one semester, second semester we have to cover it.
But you are in first semester now.
Yes, ma'am. In fact, we have completed here. 1 month
Okay,
ago we have completed.
okay. So
Just
in full MSA, it is mandatory to take a NPTEL course of 3 credits, right? Is
yes,
it?
ma'am. Yes, ma'am.
Okay, okay, okay. So you are like someone is there like you are reading offline also the same organometallic course.
Yes, ma'am.
in first semester itself?
No, ma'am. In second semester,
Okay, you
we
will
have.
be reading, means you will be reading. Now you are not reading.
Yes, ma'am. Yes, ma'am.
Okay, okay. So in fourth, it is fine, I think. Right? In fourth semester, just you have to cover 3 credits only.
Yes, ma'am.
It is fine only. Actually, the thing is, we are feeling like, okay, we are wasting our time. Too much things are there. You see, but you are interacting with people. I'm from ISC, right? Maybe we will
Yes, ma'am.
be talking about the net gate exam. You can take it as a good advantage of this course also. It is not
Yes,
like
ma'am.
that. We have to take it in a positive way. All the things we have to take it in a positive way. So if I will not be there, some other TA will be there. They are also from some IIT. Some they will tell you about many things about IIT, ISC research, and how you have to clear. You have to take uh, good things from this course. Okay,
Yes,
so
ma'am.
you have to manage your time. Don't worry, you can manage. This is like your actually we have to manage, this is true only. uh, mm, Actually the syllabus is huge for net also, but yeah, like I told you, all the topics we can't cover, but we have to like choose the topics on which we are having hold, then it will be easy. And you have to solve the questions in a smart way, like like I told you, like this you have to rule out many options, like like this you have to solve the question. If you will not be able to rule out, then you will be confused in 4 option. If you have tendency to how to rule out the things, then you will be left with 2 options, then you can answer. If something is there in your mind, if you long ago also you read about the course, then something will be there in your mind, you can answer those questions. Okay, so anything else? So shall we leave?
Yes, ma'am.
Okay, so okay, we can leave now. We will be meeting on next Saturday 3 to 5. I think some of you have shared the assignment, right? Yeah, uh, I got the assignment. Mm, Rebat has shared. Rebat, you have shared 2 assignments with me.
No, ma'am. One.
So 2 mails I got.
I think second time has been again gone.
Okay, but the full assignment. Okay, okay, yeah. Okay, I got the full assignment. I will see the questions. Then we will solve this assignment in the next week, and second week assignment also we have to solve. And it will be good if you will update yourself with your professor's lectures, then you people will be able to answer. I don't want to give you the answers of the assignments, like I will be reading the question and I will be giving the answer, then there is of no use. You people have to be little interactive. Like today also the class I felt was good only. You people have participated. Like that only we will be doing in the next classes. Okay. So yeah, if somebody wants to tell or ask something, so can we leave now?
Yes, ma'am.
Okay,
Yes, ma'am.
so okay. Bye bye. We will be
Bye.
meeting on next Saturday.
Okay.
Okay. Bye bye.